Question number 1. Convert the following parametric equation to rectangular form. X equals t squared minus 4 and y equals 1/2 t. For these, you should take the x equation, x equals t squared minus 4 in this case, and solve for t. I'll add 4 to both sides, and then take the square root of both sides. Now that I know what t is equal to, I can substitute it in to the y equation. So I take t equals the square root of x plus 4 and plug it in for t, giving me y equals 1/2 square root of x plus 4. And I've now converted a parametric equation into rectangular form. Convert the following parametric equation to rectangular form. Now this one has sine and cosine, so for this one you're going to want to use the trig identity that sine squared plus cosine squared equals 1. Okay, if we have x equals 2 cosine theta minus 1, y equals 3 sine theta plus 5, we can then solve them for both sine and cosine. Over with the x equation, we add 1 to both sides and then divide by 2. On the y side, we subtract 5, then divide by 3. So now we know what sine and cosine are equal to, and we can substitute them in. So sine we replace with y minus 5 over 3, and cosine we replace with x plus 1 over 2, and that's our answer. So we replace sine with y minus 5 over 3, we replace cosine with x plus 1 over 2. Next question, find the slope of the curve for x equals the square root of t and y equals 1/4 of t squared minus 4 at t equals 5. Whenever dealing with slope, we need to find dy over dx. Well, the derivative of y, here let's go ahead and distribute the y. It would be 1/4 t squared minus 1 if we distributed that, and the derivative would be 1/2 t. Multiply 2 times 1/4, subtract 1 from the exponent. So, that's just the dy, so that would go on top. On the bottom, we need to take the derivative of the square root of t. That's going to be 1/2 t to the negative 1/2. Just for practice, I'm going to go ahead and simplify this. You don't really have to, because we're just going to be plugging in a number, but the 1/2s cancel, and you can bring the t to the 1/2 up top. So it ends up being t to the 3/2. And then we just plug in 5. So 5 to the 3/2, which is about 11.180. When they ask for slope, remember to do the derivative of y over the derivative of x. Number 4, find dy over dx for the parametric curve x equals t squared plus 3t plus 2 and y equals 2t. So we put the derivative of y on top. That would be 2, and the derivative of x on the bottom, that'll be 2t plus 3. Next one, find the velocity functions for x equals 3 natural log of x minus 1 and y equals 4 sine x. When we're doing the velocity functions, we just need the derivatives. These are the position functions, the original x and y. So to get the velocity, we'll just take the derivative of each one. For natural log, we do the derivative of the inside over the inside. I can just rewrite that as 3 over x minus 1. And for y, derivative of sine is cosine. And if they had asked for the acceleration functions, you would just take the derivative a second time and write x double prime and y double prime separately. 6. Find the acceleration functions for x equals 2e to the 3t plus e to the negative 7t and y equals 3e to the negative 2t. So first, x prime, derivative of 2e to the 3t will be 6e to the 3t. So we have to multiply by the derivative of the exponent, which is 3, minus 7e to the negative 7t. Same reason, we multiply by the derivative of the exponent. And then y prime, we get negative 6e to the negative 2t, multiplied by the derivative of the exponent, which is negative 2. Those are the velocity functions. To get the acceleration functions, we take the derivative again. So that will lead us to 3 times 6 is 18e to the 3t. Negative 7 times negative 7 is positive 49. And negative 2 times negative 6 is positive 12. And remember, with e's, the exponents aren't going to change. We just multiply by the derivative of them. Number 7, find the velocity vector for the parametric equation at time 3. So we're still going to find the velocity equations. We take the derivative of x and get 9t squared plus 14t, and the derivative of y, which will be 6t to the 5th minus 5. But to get the velocity vector, we actually need to plug in 3 for each of those. So to plug it in x prime, we're going to get 9 times 3 squared plus 14 times 3 gives us 123. And then for the y, we need to do 6 times 3 to the 5th minus 5. So it'll be 123 and then 1453. Your answer should look like this. That's how you write a vector with those, I guess, diagonal brackets. I'm not sure what the word for those are. Looks like less than and greater than signs, I guess. And then a comma in between the x and the y value. 8. Find the acceleration vector for the parametric equation given in number 7. Alright, so we need to go back here, find the acceleration. So we'll take the derivatives again. Gives us 18t plus 14 and 30t to the 4th for the derivatives. And we're going to plug in 3 again. So let's see. 18 times 3 plus 14. We get 68 for the x value for the acceleration vector, and then 30 times 3 to the 4th gives us 2430 for the y value. So this is the answer to number 8, the 68, comma 2430. Alright, number 9. This is probably the last one we do for this video. The rest will go on part 2. Find the equation of the line tangent to the parametric equations, x equals 6t squared plus 5t, and y equals t cubed, at the point t equals negative 2. Anytime they ask for the equation of a line, you need a point and you need a slope. To get the point, we're going to take the t value, negative 2, and plug it in our x and our y value. So 6 times negative 2 squared plus 5 times negative 2 gives you 24 minus 10. So my x value is 14. And then my y value, I plug in negative 2 and cube it, and that gives me negative 8. That's my x value and my y value. That gives me my ordered pair, or my point. I also need the slope. To find the slope, I have to do the derivative of y over the derivative of x, and then plug in negative 2. So 3 times negative 2 squared over 12 times negative 2 plus 5. That gives us 12 over negative 19. And that gives us our slope. So now we have our point, 14, negative 8, and our slope, negative 12/19. I'm going to use the point slope form. Y minus a negative 8 equals negative 12 over 19 times x minus 14. And I'm just going to leave the answer just like that. If you want to solve for y, you can, but that answer is sufficient. Okay, the rest of the problems will be on part 2.